Hi, and welcome to the Microservices solution with serverless functions and serverless containers lecture. So I'm Alon Fries. I'm the Chief Architect of Code Value and CTO of Zionet. I have more than 30 years of hands-on experience, and I also Microsoft Regional Director and Microsoft Azure MVP. And I also have lots of experience using Azure Functions on different projects, and also in the last couple of years using containers, and lately using containers apps, Azure Containers apps, and Dapr. And in this lecture, I'm going to share with you the thing that I learned about the different models to do serverless computing. So we'll talk about hosting and the hosting model. We'll talk a bit about microservices, and then we'll dive into both containers and functions, and we will compare the two approaches and see what are the advantages and disadvantages of each approach. And I hope that this lecture will give you the knowledge that you need whenever you come and need to pick or to choose the technology that you use in your project. So we start from the beginning, and the beginning is a computer program, and computer program needs to run somewhere. In the old era, in the old computers, there was sometimes even a single program that ran on the machine, on our PC or Windows or Linux or Mac machines. We can execute many different processes, and process is the default or the simple hosting solution. But we can have more than just hosting our code in a process, and hosting our process on different machines or different environments. So we need a host. And of course, the operating system is there, and the operating system run our process. And the operating system can provide some, or it provides some facilities for the process, but it is not enough. If we just need to execute some code, we can use the operating system, we can use a single process, we can double click on it, we can start it from the CLI, we can set it to start whenever the computer starts, we can use Windows services to run processes in the background. But again, hosting our code in a process is just not enough. We need a better host. So over the years, there were different hosting models for our code. As we said, we started with the single program systems. For example, today, if we look at IoT system, the system on a chip, in many cases there is a single process, but even on those devices today, you see more than one process, even more than one CPU core. And we also start to see using containers on those system on a chip devices. But process itself, for simple solution, we can host our code in Windows Services, we said, or Windows Task Scheduler, if we just need a process to trigger by something and run for short times. If we don't use Windows, but we use Unix or Linux machine, we can use daemon, and there are many other old solutions. But hosting a process using this solution is not enough, because the hosting model does not provide all the things that we need to have a better environment for our code. So historically, what happened is that we moved to host our code using web services or web servers. So for example, take Internet Information Server of Microsoft or Apache or Nginx. They are all systems that serve web pages, but they also know how to host other code. For example, hosting web API, or traditionally, for example, in IIS, we could also host WCF services and so on. So web service was a good solution, but again, wasn't good enough. And we are going to talk about what we want from our host, and we'll see that it's just not enough. Another approach is to use virtual machine. So with virtual machine, provide a way to manage the resources for our code. So we can take a machine that has lots of resources, many CPU cores, lots of memory, and we can split it to different virtual machine. So we have a way to control the hardware. And also we get isolation. So if we deploy one version of the operating system, one version of our foundation, like the version for .NET Framework and so on, we don't find ourselves with the problem that we need to host another thing on the same machine, and now we have some collision between the different environments. But virtual machine, again, we need to manage it. Eventually, we will run our code in a process, and it's from the IT and DevOps point of view, it is much harder to use virtual machine than other hosting model. Modern hosting model, and we are going to talk about those hosting models. So look at functions, the different cloud functions like AWS Lambda, Azure Functions, Google Cloud Functions. This is maybe the easiest way to host our microservice solution. And again, we are going to dive into at least into Azure Function and containers, and the way that we can pack all our code and host it as a container in an isolated environment, and using container orchestration like Kubernetes, get all the goodies that we need for a perfect host. And lately, the latest technology, which is the serverless containers, that take some of the advantages of hosting functions and bring it to the world of containers. And again, this is the things that we are going to talk about later in this lecture. So if we look at traditional hosting model, we can host our process on Windows Task Scheduler. We can use Windows Service, we can use IIS, but again, these are traditional hosting, and we move now to something that provide much better solution for hosting. So what do we want from the perfect host? We need isolation, and although virtual machine provide isolation, it's just too complex to run microservice. We need security, we need configuration, we want to know what's going on with our code, so we need observability and monitoring. We need to make sure that the code runs well, so we need health check and watchdog. If something happens, we need to restart the code or port or use another machine to host our code. We need to have the ability to do recoverability if something happens. We need to support and to upgrade. We need to manage and control. We need to control all the resources and to assign different resources to different parts of or different hosts of our code. We need to run multiple executable or multiple services or many microservices. We need to manage multiple machines and multiple nodes, so we need a cluster management. We need management. We need also to have auto scaling. And sometimes we also need affinity because we want to run this specific code on this specific machine because this code needs the GPU or needs a much better CPU and so on. So we talked a bit about virtual machine. It let us manage the hardware, it let us assign different resources to different systems. But as we said before, it is too complex to host microservices. You will not spend the whole virtual machine just for hosting one service. And it is not so easy to maintain, not so easy to upgrade our code. So from the management point of view and from the waste of resources point of view, virtual machine is not the best solution for hosting our microservices. It can be a node that hosts many microservices, but not one-to-one relationship between virtual machine and a microservice. So let's talk a bit about microservices and microservice architecture. So from Wikipedia, when we talk about microservices, it's a specialization of implementation approach, which is like the next version of service orientation to build flexible, independently deployable software systems. So we are talking about software parts or software components, which are small in size, which are messaging enabled, so communication between the microservices is by passing messages. It's bounded by context, so each microservices has its own context, and it's deployed, developed autonomously, independently deployed, decentralized, and everything is using automated processes, so we can manage many different services without the complexity of doing everything manually. And the benefit of using this distributed microservices approach is that we enhance the cohesion, so each service is self-contained, and we decrease the coupling, which means that we can deploy different parts of the system without deploying all the system. We can deploy the system while other services continues to run, so we don't need to shut down the system when we update the system, and we can manage the complexity of these many moving parts. So again, virtual machine, good for all of these stuff, but bad for microservices because of the size, the cost, and the management. And when we talk about microservices, or when we talk about um, any component that we develop, we can look at the complexity. And if you look at this graph on the left side, you see that we have a single module. So this is a single module, which is a very big module. And this is the traditional monolith. So you compile and you have a single process that runs everything. Or you can have multiple single monolith process. But if you need to change something, you need to build everything, you need to test everything, you need to deploy everything. On the right side, you see the opposite. You see that you have many small parts, many small components, for example, microservices. Each of them is very small. And during the year, we wanted to be in the middle. Why? Because this is the place where the complexity is the lower. Because we have not too many parts, not too big parts. So it is not so hard to develop and to maintain them. And it also, we don't need to deploy so many different parts, and we don't need to manage all these many parts. So this used to be the task of the architect to decide how to split the system to the different parts, different components, different services, and to get to this number of services. So for example, if I need to add a new feature, I can decide to create a new service, or at least part of the feature can be implemented in a new service. Or I can say that an existing service can also take into responsibility the new things that I need to build. And this is how I can control the amount and size of each component. Nowadays, we are we are building system in this way. We are building system that we have many different parts, many different services, and they are very small. And if we compare to the old way, the complexity now is much higher. And to somehow manage the complexity, we need tools. We need methodology, and we also need tools. And there are two tools that we are going to talk about. One of them is functions, and the other one is hosting services in containers. So the need for containers, if we need to implement the system with so many different parts, and each one of them can be built separately using different technology, need to be isolated, need to be hosted with all the characteristics that we said that the perfect host has to support, then containers are the great or the best solution for that, because we can pack our code with all the different dependencies in a container, and then we can host the container somewhere. Can be locally, can be in the cloud. And if we compare container to virtual machine, we can run many more containers on one machine as opposed to fewer virtual machine on the same hardware. so we can also, or we also um, uh, enjoy the same hardware for many more services. But as we said, we raised the complexity bar, so how we can handle it. So first of all, we need to know how to use the tool and how to do the design and the implementation. And this lecture is part of the knowledge that you need to know. And also we need the methods and the tools. We must have a DevOps teams or DevOps knowledge and capabilities to automate everything. Then we can use serverless functions or containers. We need containers orchestration, so we will be able to use the hardware in the best way, and we will be able to make sure that everything continues to run, and we will have observability and monitoring and the way to do configuration and taking care about security. And we can use containers app to host those containers. So this is another way to host and to orchestrate containers. And of course, for all of these systems, there are SDKs and runtime. For example, there is Dapr, the distributed application runtime that you can use to reduce the complexity of using different microservices, of calling different microservices, of taking care about those microservices. So if we go with the approach of containers and we need to manage those containers, we need to have coordinators. And these coordinators knows how to get or how to take the different containers and run them. They can run them on a single machine, like what you can do with Docker Compose, or you can run them on a cluster, like what you can do with Kubernetes, for example. And there are many, many different platforms and technology to host or to coordinate those containers. You can use your own, deploy your own on your on-prem, or you can use cloud environments to coordinate those containers. And most of the orchestration today, most of the solutions are based on Kubernetes. So if you look at the Azure Kubernetes services like AKS or Elastic Kubernetes services, which is the EKS of AWS, or GKE, the Google Kubernetes engine, they are all based on Kubernetes, and even some higher level platform like the containers app is built on top of AKS, which is built on top of Kubernetes. And you get scheduling, you get health monitoring. Failover is something happened in your application or in your service. The orchestrator will start another instance, maybe on the same machine or another pod. If we talk about Kubernetes, you get scaling and also auto scaling just by configuring the policy for scaling. You can set different virtual network and isolate some of your services from the web. You can create gateway or reverse proxy to let client code reach your services. You have the ability to have service discovery, so you can call from one service to another just by the service name, or just by using DNS, or just by using queue names. And you have the ability to upgrade your application by deploying new container image. And you can do things like A/B testing, canary tests, and so on. So Kubernetes is today's one of the main solution to do orchestration. And as I said, there are many different platforms that underneath host or as in their core Kubernetes. But to manage Kubernetes by yourself, it's going to take lots of effort, time, and knowledge that you need to gain. So this is why we use DevOps people that knows how to manage Kubernetes, or we can take some easier environment for our hosting model. So we can take hosted Kubernetes, like all the cloud provided Kubernetes. If you need also to run locally on-prem or even in the cloud, we can use OpenShift. which also wrap Kubernetes and make it easier to manage the cluster. Or we can go even to a higher level, like using Azure Container Apps, which also hide the complexity of Kubernetes and provide us the main thing that we want to a modern host. Or we can go with functions. And if we compare the complexity of functions to the complexity of Kubernetes, we can say that the serverless functions are much less complex. Maybe they don't have the power of the Kubernetes as orchestrator, but for many solutions, functions will be much simpler and easier to use. They have this simplicity advantage. They also have the advantage of very high scale, but sometimes you need more control, and this is probably where you will prefer to use containers and container orchestrators as opposed to functions. And you can also bridge the word. You can take Serverless Functions app and deploy it as container or inside a container. And you can even merge between serverless functions and serverless containers using Dapr binding that we will see at the end of the lecture. So let's talk about serverless. The idea of serverless is that you don't care about the server. You write your own code, and then you deploy the code on some runtime environment for the function, and the environment runs your code. It's not that there is no server there, it's that you don't care about the server, so for you it's serverless. It is best for the cases that you have stateless code, so the function starts by a trigger, for example, an HTTP request, a message that gets into a queue, a change in CosmosDB collection, somebody put a blob storage on Azure storage, and so on. So there is a trigger, and then the function starts with the information that comes from the trigger. So if the trigger is HTTP request, you will get all the information about the request header and query string and body. If it's from the queue, you will get the message from the queue. And also, if you need some more information, you can bind to other resources. So function allow you to bind to different cloud resources, like binding to a queue, to a database, to a table, binding to blob storage, and so on. And so you can get information from the binding, and also you can send information later to those resources, again using binding. So when the function starts, it starts like with no data, gets the data from the request, gets the data from the other resources, run the function logic, and then return the result or store some information, again using binding. So it's great for stateless. It's also great for scaling. You pay just for, if you use the consumption plan, you just pay for the amount of memory and amount of time that the function runs. So it does not really matter if you run one function one call by follow the another one, or if you concurrently run many triggers, many calls. So if we talk about scaling, you pay the same and you get a much better scale. It's also good for sporadic work, because if you don't need to run the function, then you don't pay for the function. You can take isolated environment for functions if you need to have more control, or you can create an app service plan and choose your virtual machine that runs the function. Or again, you can go with the consumption plan, and function can be hosted on Windows or Linux operating system. There is in the runtime there is a scale controller, so it looks for the number of requests, the number of messages in the queue, and decided whether or not to spawn more instances of the function or shut down some of the instance. For binding and trigger, you have many different resources that you can trigger by or bind to get started and to get the information. If you need to have long-running function, or if you need to have some full state, you can use durable function. For example, if you need to implement long-running workflow or Saga, the Saga pattern, then you can use durable function. And the way that it works is that you call something with await, then the function finish the run, and when will be a result, the runtime will wake up the function again, like another running instance of the function, and it will skip the last call and will go to the second one, taking the result of the last call from a storage. So durable functions for longer running workflow and Saga. To show how to use function, I created a demo. It's a very simple bank system that you can deposit and withdraw money from the bank system. It's built on different microservices with different data storage. In this case, I use CosmosDB and different collections. And we have many different layers and many different services. So if you want to register a new customer, you go to the account manager with the and then to the user info accessor and store a new user and new account. If you want to get the account, so it looks the same, but here you get the information. If you want to view the balance, you go again to the account manager, but now you go to the checking account accessor and the transaction DB to get the current balance. If you want to view all the transaction history, you go again to the account manager, checking account accessor, and get all the transactions. If you want to deposit money, then you go to the account manager, go to the checking account accessor and deposit money. The same for withdraw, but for withdraw we also check the liability. Can you withdraw before we actually do the withdraw? And this is like the design of the system. So let's see the demo. So we have three different solutions, one for the function, one for the container, and one for the UI. So for the function, you can see the different services. For example, this is the checking accessor, and if you go to the code, you can see that it looks like it looks like somewhat like ASP.NET code, but you get the function name. You can use dependency injection. This is triggered by queue. This is binding to CosmosDB. This is binding to another queue, and there is the logic of the function. Okay, and you see many different functions in the function app. And to call from one service to another, you use the binding to queues, or you do an HTTP requests. So this is this was the checking account. If we'll go to the managers, then you can see the account manager, and here you can see the function that gets the HTTP requests as the trigger and use the queue to call the accessor. Okay, and all the code is on GitHub, so you can go and look and try it by yourself. Here I also added all the infrastructure using Bicep to deploy the function app and all the different resources. And also you have the GitHub action that does everything. You deploy the function, the full CI/CD with running the different integration tests. So again, you can check the solution. If we'll try the code, we can run it locally, or I also have it deployed in the cloud. So for cloud deployment, we have, where is it? It's here. We have it deployed in the cloud, so you see the different functions, also the different resources. And I also have the user interface, so here you can check whether to use the function or the Dapr app, and then you can go here, create an account. I already created one, but you can create another account, and then you can go and play with the different transactions. You can deposit money, and you will get the signal R result. Okay, and we can get the so it's, let's deposit the money, and let's get the transaction history. So we see the deposit, we see the result, we can deposit more money, and we should get back the signal R, and we should get back the result. And what you see is a cold start for the functions. So this is why it takes time, but you can see the transaction history. And I can switch to the Dapr Azure function, create account for the Dapr, sorry, and use the Dapr part to do just the same. Okay, so it's the Containers app and the Dapr. So let's move now to the other solution, which is the Containers app solution. So here you can see again everything is in GitHub. So did I switch to it? No. So this one is based on containers. To run it locally, you can see that I have a Docker Compose. So everything locally, everything can run locally. You see all the different resources are in the Compose and all the different containers. And for each container that run a service, you can also see the sidecar of Dapr, and we are going to talk a bit about the sidecar. And but this is the Docker Compose, and also here you can see the different Dapr components. And again, this is using locally, so these components run on my machine. But when I deploy the solution to the cloud, you can see again the Bicep and the infrastructure. Here I deploy it using Bicep, and I use Azure Containers App to host the different functions. And now instead of using local resources, like using, for example, if we take again the Docker Compose, you can see that I use RabbitMQ locally and local Redis, and I use local Signal R, the Signal R emulator, and I use local CosmosDB emulator. When I move to the cloud, all these resources comes from Azure, and the Dapr knows how to deploy all these resources. For example, this is locally RabbitMQ, but if now we'll go to the infrastructure, we see that instead of RabbitMQ in the cloud, we use Service Bus Queue. So for example, this is to deploy Dapr component, which is binding to Service Bus Queue. So this is a solution for using containers, and again I encourage you to go and play with the code. Everything is open source on GitHub. Let's talk about a bit about what is Dapr and what is Azure Containers Apps. So so we're talking again about containers, and containers with Kubernetes we get better control. We get freedom to choose our development technology, because function is opinionated. You need to choose whatever they offer you. Here you can choose whatever you like. You can also run for a long time, not just for short time. You can be stateful and stateless, and you get all the benefit of A/B testing, traffic control, virtual network, and so on. So as we said, better control environment, long running and scale. Even though you can host your own function, hosting with Docker gives you all the control that you need. And also you can run containers everywhere, not just on Azure. Even though functions can be hosted in containers, and then they can also be run everywhere. Serverless containers is to enjoy both serverless and container world, which means that you can even scale to 0 and to run your code, you can set a trigger, which is like functions. And so you can start your container whenever there is a message in a queue, or whenever there is an API, a REST API calling you, or gRPC calls. So, you can have triggers, and you can scale up and down those containers. Now, instead of doing it by yourself using AKS or Kubernetes, you can use Azure Containers Apps. And Azure Containers Apps, you can look at it like a simpler managed environment for hosting containers that provide you all the things that you need, like revision control, A/B testing, like split traffic, service discovery, built-in virtual network. You can manage secrets. You can monitor your code. You can scale up and down according different rules using CADA support. So you get the same main features of functions of trigger and binding, but with containers. And it lets you manage the problems or manage the complexity of microservices, all the goodies that you need. But it is not just the Azure Containers Apps. It's better when you use also a runtime that are suitable to these needs, and this is exactly Dapr. Dapr is a distributed application runtime, and Dapr lets you build the application with those tools and abilities. So, for example, when you use Dapr, first of all, you can use different programming language. Next, you can choose which service you want to use from Dapr. For example, you can use service discovery and do service to service invocation, HTTP request, or gRPC. You can you can save the state, and Dapr decoupled your code from the resources, from the component. So you save the state using Dapr API and the Dapr SDK, but then when you deploy your code, you can set whether the state will be saved on CosmosDB, on table storage, on Redis, or even on another cloud like on DynamoDB on AWS. You can use publish and subscribers, and again, in your code, you don't set the specific resource, you just publish using Dapr API or calling HTTP endpoint, and Dapr will publish using the resource that you set in your configuration. So it can publish using service bus, it can publish using event grid, and so on. Binding and triggers, as in functions, you can have an actor model if you need full state and isolation, and make sure that a single thread is only running and long runtime. And there is also a new feature that you can leverage, which is a long running workflow, somewhat like or the same functionality of durable function. If you need to have a distributed lock, this is also a new feature of Dapr. If you need application configuration and also keeping secrets, and you get observability using the different OpenTelemetry supported APM. So let's see some code with Dapr. So we'll go back to our example. We can again deposit and withdraw using now Dapr. Okay, and if we'll go to the Dapr solution, to the cloud, we can see that we have all these resources, and here we see that we have the Azure Containers App environment. Here you can see the different Dapr components, and here you can see the different apps. So let's take the account manager, for example. You can see that you can set the specific Dapr components for this specific service. You can see that you can see the current revision, so you can create more than one revision and do A/B testing. You can see the different containers, so you have a container and also the Dapr sidecar of the container that you can play with. You can set the scale, so it's from 0 to 1 in this case, and you can provide scaling rules. And if the code runs, you can also see the log stream of the code. So you can see the different transactions. And if I go back to this and try to do something else, let's like get transaction history, you can see that we got the get transaction history. And also you can have even have a console using one of the shells or bash shell and so on. And now you are inside the running container. So you can also debug your code and from the portal, which is great. So it's a very nice environment to host your application, and you get all the goodies that we talked at the beginning of the lecture about what you need from a modern hosting environment. If we compare the Azure Containers app and Dapr and containers to functions, Dapr provides better technology for hiding and decoupling the Azure functions, although Azure Functions also provide decoupling using triggers and binding, but you still need to use the specific types of the specific resource in the function, while in Dapr you use Dapr SDK or just HTTP or gRPC requests. So you're less coupled to the technology when you use containers and Dapr. It's standard mechanism. It's cross-platform. You can deploy your code not just on Azure Containers apps, but everywhere. Even running with no containers, and Dapr works. And yet there is now a new extension for functions, which is a Dapr extension binding for functions. So you can enjoy both worlds. You can create a Dapr binding, and then you can use the trigger and binding of Dapr using Azure Functions. So if you like to merge the two worlds, now you can. So to finish everything up, we talked about the Microservices architecture approach and how it raises the complexity bar, and that we need the solution to take care of all of this complexity. And then we talk about hosting and the hosting model and what we want to get from the perfect host. And then we saw two serverless approach. One is the serverless functions approach. Another one is the serverless containers approach that can be also trigger and bind to different resources. Which one should you use? If you don't have DevOps team in your project, if you want a simple solution but in somewhat more opinionated, then go with functions. If you need something which provide you much better control, that you can deploy everywhere, run everywhere, and decouple from different resources, and also use resources that coming from other cloud providers and on-prem, then go with containers in Dapr. And you can enjoy both with this new Dapr binding for functions. So have a nice rest of conference, and thank you.